This is differential equations, section 6.1. We're now going to do activity 6.1.2. So for part A, we have this function, capital F of s is 2 over s squared. And so to find the inverse, there is no formula for it. You just have to do the Laplace transform of a whole bunch of functions and make a table and then say, okay, where does this fit on the table? Or you just use Sage, which also works just fine. It's computers are often better at using tables than humans are. So here, if you look at, I've got this table from your textbook, and I need to find what things look like they are something over s squared. Well, right here, s squared would be n equals 1. And so that means that the Laplace transform of t equals 1 factorial over s squared. Okay, and the Laplace transform is linear. So the Laplace transform of 2t would then equal 2 over s squared. Okay, so that means Laplace transform inverse of f equals 2t. And we're done. Okay, let's move on to part B. So for part B, f of s equals 1 over s to the 4th. Okay, so similar thing. Now, I know that the Laplace transform of t cubed will equal n factorial. So 3 factorial is 6 over s to the n plus 1. Okay, using, of course, this one right there. Okay, now I don't want 6 over s to the 4th, I want 1/6 of that. So that means the Laplace transform of f will equal 1/6 of this. 1/6 t cubed. Because if I threw in a 1/6 here, we'll cancel out the 6. Okay? So if you didn't catch that, once you kind of know the rough idea of what kind of function it is, like a t cubed, it's a linear function. So 1/6 t cubed will then equal 1/6 times 6 over s to the 4th equals 1 over s to the 4th. Okay? Now let's do part C. F of s equals 2 over s minus 3 squared plus 4. Okay, now we're having some fun. Now, what sort of things in here look like that? A number over, so sine of at looks a little bit like that, but then to shift it, you need e to the at times that. So e to the at sine of bt. So here, if you look at this, the top is b and then b squared. So b is 2, and then minus a, so a is 3. So that means that over here, Laplace transform inverse of f equals, I'm just going to write down my a and b real quick, because it is a equals 2, b equals 3. So then I'm looking at e to the 2t times sine of 3t. Okay, let's do part D. So in part D, we have f of s equals 2s squared divided by s squared plus 1 times s minus 1. Okay, fun. For this one, let's think. So it looks a little bit like a sine, but also multiplied by an s minus 1. Okay, so what sort of things can we say about that? Well, I think we need to do some algebra first. So if we see something like this and it doesn't match anything here, then we don't have to panic. We can always do, what's it called? It's not partial fractions. It's the thing where you find, my mind just went blank. All right, so 2s squared over s squared plus 1 times s minus 1. So that's equal to as plus b over s squared plus 1 plus c over s minus 1. Okay? So this is a trick we learned in Calc 2. So then here we gotta then kind of put everything back together and find out what a, b, and c are. So that's equal to as plus b times s minus 1 plus c times s squared plus 1 all over s squared plus 1 times s minus 1. Finding the common denominator, you multiply by each term to get the common denominator. Okay? And so then I don't need to worry about the denominator anymore. I just know that 2s squared equals, so let's FOIL this. So as squared, let's just get our s squared term. So then my s squared terms are going to be, there's an a and a c. So a plus c s squared. Then what sort of s terms do I have? I have a b, I have a negative a, that's it. B minus a, s. And then what sort of constant terms do I have? I have a negative b and a positive c. All right. So the fact that there's no constant term here means b equals c. The fact that there's no constant term here means that a equals b. And so then these two numbers, which are the same, add up to 2. So they all equal 1. So that means you've got, move to my new piece of paper. So restate d, restate my function as being, instead of being 2s squared over, it's s plus 1 over s squared plus 1 plus 1 over s minus 1. Okay, now let's see if things match up. So the s plus 1 over s squared plus 1, that looks a little bit like e to the at, this one, e to the at times cosine bt. Okay, so if a is negative 1, then, oh boy, that still doesn't work out. Well, maybe we need to break that up. So that means f of s equals s over s squared plus 1 plus 1 over s squared plus 1 plus 1 over s minus 1. Much better. So then now we have an s over s squared plus 1. So that's cosine of t. So this one corresponds to cosine of t. This one corresponds to, so sine of t. And this one corresponds to 1 over s minus 1 e to the t. E to the, with a equals 1, so e to the t. Okay, so that means the inverse Laplace transform of capital F equals cosine of t plus sine of t plus e to the t. Okay? All right, our last one is part E. So here we have f of s equals 2s minus 13 over s times s squared minus 4s plus 13. Okay, fun, fun, fun. So now we need to do, so s squared minus 4s plus 13. That is a quadratic that does not factor. The plus 13 makes it so that it doesn't have any real roots. So we're talking, so let's do our partial fractions first, and then we'll deal with that guy later. So partial fractions first, that's equal to a over s plus bs plus c, bs. All right, bs plus c over s squared minus 4s plus 13. Okay, then that means that you kind of find the common denominator. That's going to mean that 2s minus 13, I'm just going to skip a middle step here, equals a times s squared minus 4s plus 13 plus bs plus c times s. Okay, so let's kind of get this, sorry, you can't see the end part there. Let's get this guy so that it's all s squareds, s's, and just normal numbers. So our s squared terms, there's just one s squared, nope, s squared terms are a and b. A plus b s squared. And how many s terms do I have? I've got c times s and then a times negative 4. So plus c minus 4a times s. And then how many constant terms do I have? None here. Plus 13a. Okay, so I've got negative 13, positive 13. How nice of them to give me nice numbers. So that means a equals negative 1. And then if a is negative 1, then you have b, a plus b must be 0, so b equals positive 1. And then c minus 4a is 2. So then c plus, so minus 4a would be plus 4, so c plus 4 equals 2, so c equals negative 2. Okay, so then that means that f of s equals, a is negative 1, so negative 1 over s, plus b is 1, s, and c is 2, minus 2 over s squared minus 4s plus 13. Okay, sorry, you can't see that. Now, this guy, that doesn't look anything like my table, does it? So the next thing we got to do is complete the square. Okay, it's almost like all these algebra things you learned in high school are actually useful. So completing the square, you take the middle number, divide by 2 and square it. You really want a 4 there, not a 13. And so divide the 13 into a 4, like 13 is made up of 4 and then 9. So f of s equals negative 1 over s plus s minus 2 over s squared minus 4s plus 4 plus 9. And that is s minus 2 squared. So, get a new piece of paper here. So then, f of s equals negative 1 over s plus s minus 2 over, this becomes s minus 2 squared plus 9. And look at that. Okay, so now, let's see. So, let's see. Have I introduced you to the mu CT yet? Let me check. So, the mu c of t is this function that is 0 when t is less than, that shouldn't be 0, that should be c. C, and 1 when t is greater than or equal to c. So it's this function that kind of determines when things are positive. So when I've got this function, when I've got a function here that looks like a s over s squared plus 9, which would be something you would see over here, like s over s squared plus 9. That looks like a cosine, but it's shifted over. So how do you get something that's so when you have this function here, oh, I don't need that. Okay, I just need this. So you have an e factor there. So I don't even need mu, although it's nice to know for the homework, I'm sure. So here, my function, I want to kind of think of f of s minus 2. Let's think carefully through this. So basically, you look at e to the at, it shifts s minus 2. And so when you've got like a minus 2 situation here, then we can do, this one is pretty simple. That's just negative t. And this one, it's going to be, think of it as the s minus 2 makes it have, so if you look here, the minus 2 makes it have an extra e to the 2t outside. So e to the 2t, and then the actual thing that's going on is like, think about this new, like s minus 2 as the thing, as the s, then that looks like an s over s squared plus 3 squared, so it's sine of 3t. Make sense? I guess I could have just split that up. Also, could it? Well, no, because you don't want to do that because of the s minus 2. So yeah, so that means the Laplace transform inverse of f equals negative t plus e to the 2t sine of 3t. All right, and that completes this activity.